So yeah, thank you for the introduction. This title, as we talked about, is getting the most out of VR, or as I like to call it, bridging the gap. Um, Bridging the gap between the vision of VR and the reality of VR. Invariably, when we talk to any VR developer, they tell us, before we start a VR project, our vision for it is this big. But yet, when we're faced with the realities of the performance of today's game technologies, we have to shrink our vision so that we can get the performance that we need. So, yeah, we're a company that makes another game engine, but highly focused on VR and very, very performant VR. Now, I have been in 3 radically different time zones in as many days. Exactly 1 week ago today, I took this picture. Anybody recognize that? It's the Arc de Triomphe in Paris. And I was on vacation with my entire family, my kids, spouses, 2 grandbabies, even my mother-in-law. I know mother-in-law jokes even translate into Asia, but 14 people for a week in Paris, and it was phenomenal. This is an experience that's difficult to replicate in VR. You don't have the smell of the baguettes and everything else, but I do believe that certainly mixing this with AR is certainly the wave of the future. So I'm almost as excited to be here today talking about mixed AR as I was to be in France last week, if you can believe that. So to give you a little bit more of my background, as was just mentioned, I've been in the industry more than 20 years. I've been an executive producer, product manager, and held marketing and biz dev roles at Sega and Activision. I did that for about 12 years. About 9 years ago, I moved to the technology side of things and worked for Emergent Game Technologies. If you remember the Gamebryo engine, I was their VP of marketing, then switched to their VP of Asia. Then I was with Crytek and was responsible for launching the Cry engine in North America and Asia. Then I was with Unity for 5 years. And what's interesting is I joined Unity when worldwide it was about 90 people and had no presence in Asia. Grew the business in Asia, and great company. I still got great friends there. Some of you are here today. But what's interesting, I've now joined MaxPlay when it's about 90 people with no presence in Asia. So it's kind of a good thing that I'm looking forward to. But I also have lived and worked in Japan, spent about 8 years of my life in Japan. And 私は日本語はできますが、残念ながら英語はそんなに上手くないです。I speak Japanese, and unfortunately my English isn't very good, so please bear with me. So to give you a little bit of the history of MaxPlay. So we're a private company, like I said, of about 90 people in Austin and in San Francisco. Our staff has a really diverse background that comes from both the games industry and also the enterprise software industry, building SaaS platforms. Our CEO, for example, was former vice president and general manager of EA Partners and has managed some of the biggest franchises in the industry. Collectively, our executive team has managed about $20 billion of franchises. And so it knows games. It's a phenomenal team, and it's kind of exciting. So we're in this massive, this thing keeps falling off, I'm going to hold it. So we're in this massive AR and VR transition. We've all heard that it'll be about $120 billion a year by 2020. It's a blue ocean of opportunity. Some really exciting things going on. When PSVR launches later this year, they'll have more than a 35 million installed base there. In some parts of the world, Samsung has been bundling Gear VR with the S7. But still, ultimately, it's software that drives hardware. But as we know, software development for VR is really hard. Without high frame rates and low latency, it can literally make you sick, thus the puking pumpkin here. But with companies like Sony insisting that your game never drop below 60 frames per second, performance is not a luxury, it's actually become a requirement. And that has made it difficult for users of the currently popular tech that is out there today. the market leaders were caught a bit off guard. So with the current major solutions that are out there today, it's written basically on 10-year-old technology, and it was caught a bit off guard. Here it talks about NVIDIA saying virtual reality requires 7 times the power of the normal game. Oculus Rift's Achilles heel is requirements. And so there are all these challenges. But game engine use throughout transitions has been quite interesting. You see this here as game industry revenues rise, the green portion there, the use of engines rise. And these game engines help developers deal with these transitions. And of course, there were very few people using game engines when Unreal was launched back in the late 90s. Unity started about 2001, really made a lot of progress with their mobile applications when they launched in about 2008. But they're still 10-year-old technologies, and they were developed before multi-core. They were developed before all these VR requirements. They were developed before the cloud, and they're not natively custom to doing that. And that's kind of where we intend to come in. So basically, the message is your machine is fine. It's your software performance that sucks. Now, if any of you are carrying a Galaxy S7 in your pocket, you've got an 8-core device. In Asia, for some reason, Samsung shipped it with 8 cores. In the US, they shipped it with 4. But most of you, you've got an S7, you've got an 8-core processor in your pocket. But with any of the currently available tech that's out there today, not all of those cores are being used. You'll end up with 2 to 3 being used. Some of them hit kind of hard, others hard not hit at all. And it's very hard to do that. So what do you need? What do you need for effective VR development? First, you need high-performance software to minimize data contention, to maximize and make efficient your CPU and GPU. You need iteration. You need rapid iteration, more so than any before, because VR development is so hard that you've really got to iterate quickly to get that process done right. And you need instantaneous preview on devices. Next, you need extensible, service-oriented architecture so you can easily modify your tools. And then, ultimately, you need really, really good telemetry, eye tracking, motion controls, a wealth of analytics from development all the way through deployment. And there is no one solution that covers all of these very well. So, what are your options? Do you build these tools yourself? And some have done that. Or I'm going to introduce to you today the MaxPlay GPS, the MaxPlay Game Development Suite. And what it is, it's highly performant software. We have a proprietary MaxCore technologies that really maximizes the use of all cores. It's built natively with this in mind. And you'll see some examples of how that works. Rapid iteration, MaxPlay really excels at. It's really cool to see developers across the hall or across the world working real time developing a game. So it's very, very cool to see. Google even has referred to it as the Google Docs of game development. So then a very extensible, serviceable architecture. If a third-party tool addresses a WebSocket, you could very easily integrate it into the MaxPlay GPS. And then we've got unparalleled analytics that are used in this process. Now, VR is quite a bit different today as it was envisioned several decades ago. So first of all, let me talk a little bit about our MaxCore technology, which really takes advantage of CPUs and GPUs. So the CPUs are fully utilized, and the GPUs are managed much more efficiently. We use a light index deferred or forward plus rendering that is much more efficient for GPUs than deferred rendering, for example. And it reduces VRAM consumption as well. So you get really, really great graphics and a lot of complex scenes rendered with very little GPUs. So we talked to Intel about what we were doing, and they were skeptical. Do you really offer this kind of performance? And so they issued us a challenge. They said, we want you to build an app, and from 2 cores to 6 cores, we want to see you get an improvement of 25%. And if you do that, we'll believe you. So we built an app. We ran it on a 2-core processor, and then ran it on a 6-core processor, and we didn't get 25% improvement. We got 600% improvement. And Intel became such believers that we were the only game engine tech that they featured during GDC. So the performance of it was absolutely mind-boggling. So to give you an example of that, here's videos from those tests. So on the 2-core test, so what we did is we built this flocking demo, and it had standard flocking algorithms. There's no particles in this at all, but this is 10,000 3D game objects. There are 8 predators, and we've got avoidance scripts in there, so the flockers are avoiding the predators. And here we are in 6 cores running at well over 100 frames per second. Now, that's cute and all. That's a cute tech demo, but how does that transfer to a game? So to demonstrate this, we hired The Mill. They're a New York-based visual effects studio, have done a lot of work in Hollywood. And we told them to build us a game environment with an Asian theme. The building alone that you'll see in this has 1.5 million polys. There's 4.5 million polys in the scene. You'll see some really complex rendering while never dropping below 100 frames per second. And so here's what that looks like. You notice the dragons flying in there? I'll talk about those dragons here in a second. So you saw some of the dragons flying around in there. So fun story. Even though the frame rate in that never dropped below 100 frames per second, you can actually ride the dragon in the VR playable of this. And the record before somebody throwing up while riding that dragon was 3 minutes. I made it about 2, and I took it off just before puking. So every time we let somebody play that in VR, we always have a trash can nearby. Riding a dragon flying through that scene, no matter how performant it is, it makes you pretty sick. So kind of fun. We also did this. We hired some expert Unity programmers and some excellent Unreal developers, the other guys. And the performance that we got, in some cases, was as high as 260 times the performance. I won't mention which one, but in one of those, the performance was 3 to 4 seconds per frame. So just phenomenal, the performance we get out of that. So how do we do that? We fully utilize all the cores. And if you look at the other guys, they hit 2, maybe 3 cores sometimes. It's very inconsistent. The guys we use actually very heavily scripted it to try and use more cores, but that was the performance that we're getting. With Max Play, you're hitting it all the time. So now let's talk a little bit about real-time collaboration. So this is a scene from our editor. You could have an audio engineer, a level designer, a lighting designer, gameplay engineer, artists, all kinds of people. You can have working in the same scene real-time, whether they're, like I said, across the hall or across the globe. So it's real-time collaboration. The collaboration tools that are out here today, it's still a very serialized process. The gameplay engineer might make a change, has to do a new build. Now that new build could be done in the cloud, but then the artist has to access that, and it's still somewhat iterative process where this is truly real time. And so you could end up with something like this. You could have somebody in Austin, Texas. You could have someone in Beijing. You could have someone in Singapore. You can have someone in Santiago, Chile. And they're all working in the same scene, real time, in a cloud-based SaaS environment. So that's literally what it could look like. And it's really, really cool, and it's really, really fun to see. And so of the 4 things I talked about, being performant and being real time, I covered those pretty heavily. The last one I'm going to touch on just very, very briefly. But we're architected for performance, extensibility, and a whole lot of telemetry, which you need throughout the development process. We've got user data and telemetry and all that built in a secured layer, and then that is exposed to a REST API. Very easy to integrate third-party tech into this, and so we really believe in true democratization of game development. So the number one question that I get as we talk about this is when? When can I use it? When can I get this highly performant engine? And I'm happy to announce that we are going to issue some early access starting next month. And we're doing a Founders Club program where we want developers who are really interested in this to use it, start playing with it, start building things, give us a lot of feedback, and we'll do a broader beta later this year. And then we'll commercially ship it when it's damn good and ready. But it's really going to be hot. But we're starting early access. If you're interested in that, you can certainly talk to me about it. It's been in development for about 2 years, and so it's really come along pretty quickly. But we believe, given the performance, given the real-time collaboration element of it, given the extensibility of the engine, we believe it is going to be fairly disruptive. And so with that, we have time for some Q&A. It's going to take a long time to perfect that. It's not going to happen right away, and we do need to start. We need to start, and we need to fail, and we need to fail often, and we need to learn from that, because it is going to take a long time. In some respect, the hardware makers themselves are addressing this problem. The first time I used AR, the latency of it was over 100 milliseconds, and I couldn't play for more than 5 minutes without getting a really bad headache. And that has gotten so good with most of the VR makers right now that that's no longer an issue. And I believe that over time, developers are going to learn how to build experiences that you can play for a long time. Now, having done business in Asia for 30 years, I'm old. I turned 50 this year. Or as I like to say, I hit the 21st anniversary of my 29th birthday, so I'm only 29. But in my 30 years of doing business in Asia, I generally don't get a lot of questions, so some I prepare on my own. So in my FAQ, I'll share with you another question I get a lot is, you're developing an engine with some very entrenched players in the market. Are you crazy? And the answer to that is absolutely, we are crazy. But we believe it's important to be crazy to do big things. And fortunately, we've got a lot of people believing in us. We are very well funded. We've got some additional investors wanting to come in as well. A lot of people believe in this vision that we have, and so we believe we need to be a bit crazy to do something really big, and we believe it can be disruptive.
Quick question. So are you targeting just a PC platform or the mobile devices?
No, so PC and mobile are our main targets right now. But we have a lot of discussions going on. I don't believe we're going to go too crazy with several dozen platforms that we support. But right now it's focused on PC and mobile, but we'll be extending to other platforms as well.
You said that when your players are driving those dragons, it only takes 3 minutes for them to throw up.
Yeah.
So what are you doing to address that? Because yeah, I've heard.
That's more of a gameplay thing than it is the technology itself. if I were to ride a roller coaster as severe as this in the real world, I would throw up. And so developers, I think, are going to need to learn to create experiences that aren't so real, or you're going to get real-world effects in a virtual environment. I do think that's a big challenge as developers learn to create VR. Excellent. Thank you, guys. Appreciate your time.